Hello and welcome to my level, the time reversal train. You start here in a tunnel that has partly collapsed, and you can see a train that has crashed in here. You can see that the debris has iron rods that point towards the end of the train to guide the player over here. Here I'm using rhythm with the chairs to get a sense of progression. And here you can see symmetry with the doors, and I'm breaking the symmetry with these doors being open. To guide the player out here. I'm also guiding the player out there with guiding lines on the chairs that have fallen, and also the ventilation that is pointing this way. Here you can see that the debris has iron rods that all point in this direction, and the debris doesn't have iron rods on the other side of it. So I'm guiding the player over here through that method. And here I'm guiding the player into the train cart up there. With the train track that is pointing over there, and also the debris that is pointing over there. Here I have plates on the roof of the train to form rhythm to get a sense of progression. So we go into the train here, and we can see that the furniture have fallen, and they form guiding lines leading over here. And the train cart falls over. Here we can see that the debris is pointing towards the entrance of that train cart. So we go over here, and we leave the end of the train cart here, and the debris is pointing this way. We enter a train station that has partly collapsed. I'm using the debris to guide the player inside of this train cart, which is the front of the train. So we go into the control room, and we have a button here, and then we can start the train. You can see that the bridge has collapsed, and that it's collapsing in reverse, with missiles being shot in reverse. So you get a sense that time is reversed. And we enter a train station, and the track forward is blocked, so we can't get anywhere further than this. And the train station has been repurposed as a military base. The cannons all point towards the field down there to guide the player over there. And here we can see an explosion in reverse and a bomb that is being dropped from fighter jets in reverse. And here we can see tanks exploding in reverse, and the cannons that shoot in reverse. I'm guiding the player towards the big tent over there. I'm using hierarchy of size to make the big tent stand out. And the cannons on the tanks, they all point towards that way. And also there are guiding lines on the tanks themselves that lead the player over here. So the sandbags also form a path, so to say, this way. And the character inside of the tent draws a lot of attention to it to guide the player inside of the tent. So you reach a map in here of the area, and this is the end of the level, where you have reached a military base. Okay, now I want to show you some of my blueprints. I'm going to show you the button that triggers the train, and also the door on the train and the train itself. So let's see here. Let's start with the door. The door looks like this, the door blueprint. It's attached to the train as a child actor here. And so we have a box collision, and on component begin overlap, we check that the overlapping actor, the other actor, has the tag player, and then we call the function open. And similar thing here with on end overlap. So if the player is ending the overlap, then we call the function close. You could also check that the other actor is the player by casting to the specific class. In my case, the BP first person character. But this is not a very good way of doing it, because it's expensive memory-wise, since it's referencing this specific class, and also it's not very flexible in case you want to change the player blueprint to something else. So this is more flexible and cheaper, but then you have to make sure that the player has the tag player. Okay, so let's continue in the train door. On open, I start a timeline open that is going from 0 to 1, and I use this alpha value to lerp a vector from 0 to 160 on the y-axis, which is just a value that I found was suitable for me, 160 there, and minus 160 for this door. So I'm plugging the this vector into the left door, and I'm multiplying with -1 to get minus 160 for the right door. You can also use a lerp vector instead of this ease function. It's basically the same. If you want to, you can lerp a rotator to set the relative rotation for the doors, but I'm not using that. So that's it for the door. Now I'm going to show you the button. You could enable input on the controller in this button, and then test if you press the E key, you could start to interact. So you could do this. Let's see, input E key, and then we can press the button. I'm using another interaction system that I'm not going to go through in detail, but the player has an interaction component, and when the player presses E, it checks that it has a variable widget blueprint component interactable input. If that's valid, then it tries to interact in that component, which in turn calls an event dispatcher on interact. And then I put that widget blueprint component in the button that I want to be able to interact with, and then I use this function on interact to trigger any function that I want to use, but I'm not going to show you that in more detail. So when we activate the button, we want to start the train. You could use a train reference to call a specific function in here. Let's say start move spline. You could trigger that from a specific reference, which is an instance editable variable. So I could set this variable to the train here, and then I can call that function. I'm using another way of activating it by applying damage and checking that the damage causer has a trigger tag. I can see that. You can see that here, trigger. I'm not going to go into depth here, but it's basically better to do it either this way or with a blueprint interface or with a blueprint component instead of having an instance editable reference. For several reasons, this is more costly memory-wise, and it's also less flexible. Because if I want to activate, like, say, 5 different blueprints, I don't want to have specific references to each and every one of them. But that's it for the interaction system. I basically activate the train on any damage. I check that the damage causer has the tag trigger, and then I activate it. You can use a blueprint interface to activate it. So then I start moving the train along the spline. So the train has a long spline over here, you see, and I play a timeline that goes from 0 to 1, and I use that alpha value to get a distance along the spline from 0 to the end of the spline. And I'm using that distance to get a location along the spline and a rotation along the spline. Then I'm setting the relative location and rotation for this tram pivot. Tram or train, whatever you want to call it. Yes, that's basically it. You could use an event tick and check if it's moving, but this is what we learned at school. But this is more costly performance-wise because this runs every tick, and the timeline runs on itself, so it's not even necessary. You can just start it with one function. Okay, that's it. Thank you.